Hi there, this is Kristen Rossler. I'm going to go through the week 4 enzyme catalysis lab that's using yeast and hydrogen peroxide and catalase. Anyway, here we go to show denaturation of enzymes, etc. All right, so the setup each week, or this week rather, is going to look like this. I've kind of played with it over the years, so again, feel free to do what you want, but this is what I found has worked the best. So I have them using this little plastic container, make sure, of course, they have those out. And I added a stir bar and the stir plate, obviously, the magnetic stir plate to it. I just tell them to, they kind of get a kick out of using the stir plates for the first time. So I try to remind them just to kind of get it good and mixed and use that same speed for all the subsequent experiments because they have to do several runs today. So it's going to look like this. The oxygen sensor that you see here, let me put my finger over, where's my finger? Oh, there it is. The oxygen sensor, if you don't see them out, sometimes the lab manager, she has them in the refrigerator because they're supposed to be kept cold. So after your lab experiments are over, if you don't mind grabbing them and putting them in the refrigerator, if it's going to be several hours or whatnot till the next group comes in. And yeah, so it's going to look like this. They're going to put the various solutions in, and I'll show you that in a second. And always get them to add the hydrogen peroxide last. Because obviously once they add the hydrogen peroxide, the substrate, the chemical reaction is going to go pretty fast. There's one run, there's a couple runs actually, but mostly run 2, it goes really aggressively. And so I typically warn them that they need to hold on to it during the 300-second run that they're going to perform, especially for run 2. It can happen actually for other ones, but mostly run 2 is the one where it's an issue. So here is the Pasco probes passport thing. I gotta find the name. It's the oxygen gas one sensor. So sometimes I found that the lab techs sometimes will not put the right passport out. So make sure you check that ahead of time to make sure that the right oxygen gas sensor, there's a bunch of them, so make sure that that one is the one that you have. And if you are needing it, there's usually some in the plastic bins on the side of the room. It's obviously then going to be plugged into the Spark link, and there should be a cute little cord that connects it to the computer, and as such. All right. So again, once they are going to take a reading each time, let me just show you again how that works because I don't think I did a very good job before. They're going to go into that middle selection, and so you're going to again get in a Spark view. They're going to use the sensor data, and when you open it up, let's see, how are we going to do this? Hopefully it's working here. Let me cancel that. Oh, let's see, I'm going to build a new experiment. All right, so we're going to build a new experiment, and this one is not working super great. Why is it not working? Oh, it's because I'm in a rush. Come on, buddy. What the heck? All right, oh wait, shoot, it finally worked. That was super annoying. All right, and just to remind you, if you're on the Providence campus and you need a password, we have a white sheet on one of the front lab benches that says, I think, security 2468 or something. It has a login name, and a universal login, and a universal passcode, so you can use that if you want. Oh, I see what I'm doing. Golly, I apologize. We have to edit this. Oh, because I'm in a rush. Whenever I'm in a rush, right? So we're going to build a new experiment. All right. And again, they're just going to be making a single graph, so they can just select this one over here. They're going to be graphing their data, so it's this top left, if you can see that. I think that shows up. There you go. And here we go. We're almost ready to go. We need to make sure our units are on the sensor is selected properly. So we're going to go over here, and it hopefully is going to sync up with the sensors. Let's see, why is the sensor just not working? Oh, shoot. This normally works wonderfully. All right, so hopefully if you get it, oh, come on guys, I don't have time for this. Usually it's going to sync up. Let me see if I can play with it just a smidge and get the probe to sync. Make sure it's all plugged in properly. All right, Well, anyhow, supposedly, and hopefully when you do it in lab, something's not working right, obviously. You would select sensors, and you're going to be looking for oxygen gas, and we're doing it, I think, percentage, okay? So oxygen gas percentage is what you're going to want to select. Now, each time the students do a run, again, to start off with, they're going to put all their materials, of course, into their beaker, into their flask, and then I tell them to be like a pit crew so that they're ready as soon, so somebody is by the computer, and the person, as they're pouring the hydrogen peroxide into the beaker, as soon as the hydrogen peroxide is in and the probe gets re-administered to the top of the flask, somebody over here on the computer is going to select that green start button at the bottom, all right? And let's see, so if they hit the green select, they should then run it for 300 seconds. The time interval down here on the bottom of the x-axis, you can actually manipulate it. You can change it to seconds or minutes, so if they want to do that, they can do that. I think it's right over here on the time. Where is it? All right, so there, if you see there's a little time option. So it usually runs in seconds, and so they could change it if they wanted it to minutes. And of course, get the 5-minute run. All right, so each run they're going to need to run it for 5 minutes, and then they're going to need to get the data at the end. So each run is going to start popping up here in terms of this right side. There's going to be a run 1, run 2, run 3, and it's a cute little color that they use for each one of them. And so as they get there, as their runs are complete, each time they're going to need to collect the data from it. So they're going to select down here in the lower toolbar, kind of like what we did last week, the epsilon or the sigma, and they're going to select on that. And now they want to select the minimum and the maximum. So they're going to need to select both of those two values, and then it's going to pop up on the line. Again, it's a really small number. I apologize. There are some magnifying glasses that Tracy has. So they're going to record their minimum and maximum for each run in their data sheet that's in their lab template. All right, and then they're going to be calculating the rates at the end. It's really not that bad. The bad part of it is trying to convince them how to do it. So I put up here on the board kind of a, I do this actually every year, and it seems to help make things go smoother because they often just need help seeing what it's gonna look like. So for the first run, all groups are going to perform that one. It's the negative control, where they're just doing the basic breakdown of hydrogen peroxide, because there is a background level of decomposition to hydrogen peroxide to form the water and the oxygen gas, and it's pretty benign. So I show them that this is what we're going to look like. Now again, I've changed this from the protocol that's posted online just a smidge. I have the final volume of all runs being 100 milliliters. Just to keep things consistent, and I again use that stir bar for all of them and keep it kind of consistent. It's just a better way of obviously doing an experiment. So the first run, they use the 20 mils of hydrogen peroxide and then 80 mils of water, and of course add the stir bar, and then they're going to do the 300-second run, and then take the minimum and maximum. That's all groups, so that's the negative control. Then, after they're done, they're going to pour all their solutions into a waste bucket that should be at each of their benches. We don't want, of course, all this stuff going down the drain, because there can be a lot of oxygen gas that builds up in the drains, and they can explode, which would be bad. So then they're going to do run 2. That's the positive control, and this is the one that's most robust. Does that make sense? So again, have them hold their hand on the oxygen probe as they're setting this one up. And here, again, what they're going to do a little bit differently is the only thing that's different, obviously, is they're changing the water volume, because they're adding 10 mils of the yeast solution that Tracy is going to have made up. And then they, again, as soon as they're ready, have them add the hydrogen peroxide last and be ready to start their oxygen sensor, because it goes quite robustly. All right, so all groups are going to do this run and this run. Then what you're going to do is, I typically have, about 4 groups. You may have 5 groups, but I usually have 4 groups. And I tell one group they're group 1, I have another group is group 2, and then group 3 and group 4, etc. And then if you do have a group 5, just they can pick whichever one they want to do, etc. So what they're going to do for run 3, it's very similar. The only thing that's different now is we're going to increase the pH by adding sodium hydroxide. So there's little bottles that are available. Sometimes I try to have them actually do it in the hood, the group that's going to be doing that, just because sodium hydroxide can be a little bit gnarly. And so that's the setup for that one, and usually it has a pretty robust denaturation effect. Another group entirely is going to do the decreasing pH, and of course instead of using sodium hydroxide, they're going to use the hydrochloric acid, and again I have them do this in the hood. And of course remind them that you have to add acid to the water, right? So they're going to add the water first, the yeast first, I think, and then I have them add the hydrochloric acid. Yeah, it's just remind them that there's, acid goes into the water, and then it's dilute enough typically that I can, you just don't have to, I don't think there'd be any issue because it's such a small amount, but on the off chance that it is, just remind them that goes in to the water. Again, they're going to see a pretty robust denaturation effect for run 4. Then for group 3 and group 4, it's pretty much the same as what we were doing before. They're going to do repeat run number 2, all right? And group number 3 rather, in run number 5 is going to increase the temperature. And so Tracy has pre-boiled some yeast. So instead of using the 10 mils of room temperature yeast that has, they're going to use 10 mils of this boiled yeast. So you might want to walk around and make sure that they actually understand which yeast they're using. Similarly for group 4, for run 6, they're going to be using the pre-chilled yeast. Sometimes I have them pack this one on ice a little bit. It doesn't work very well, just interestingly. The yeast are so tenacious that they will continue to, it really doesn't have much of a denaturation effect. Yeah, so anyway, and then, so then they're done with, then we combine all their data. I have them usually come up to the board and write, or come up to the computer and we, write on all their values after they determine their rates of change. And of course on the template it says, I think, reminds them that it's just the change divided by 300 seconds. All right, the other one that they're going to have to do, which is often confusing, is the change in salinity. All right, so this one's a bit of a pain. So I have them do each group again. I'll have group 1 do 7A, and I have group 2 do 7B for sodium chloride. And then for group 3 and 4, I do the same thing for ammonium citrate, or ammonium sulfate rather. So we have 2 stock solutions of 5 molar sodium chloride and 5 molar ammonium citrate rather, and you're going to get them to practice a little bit of how we make dilutions using, of course, M1V1 equals M2V2. So just for an example, so for run 7A, for both the sodium chloride and ammonium sulfate, the final concentration of salt that works moderately well is 0.75 molar. All right, and so we kind of go over the math for that one. If you want to change the concentrations, go crazy. But of course, we just want to make sure that we're accounting for the volume is going to be 100 mils, and not that we get too high. And then for the second one, something you could do is the 1.5 molar, which obviously would be 30 mils of the 5 molar salt, and you would just have to make sure that they're changing and decreasing the water concentration, the water volume, so that again the total volume should never exceed the 100 mils. All right, hope you have fun with that. It's a little bit easier actually, I think, than the week 2 lab and our week 3 lab, whichever one we just did. And I'll just warn you, week 4, that's next week, is again one of the harder ones. It's not that hard, it's just that there's a lot of stuff that's going on. So I'll do another one of these videos then. All right, if you have any questions, let me know.